Hello everybody, I'm Javier Bofarull from Spain, and this is the fifth assignment for the course Introduction to Music Production. Today I'm going to talk about two audio effects related with delay. This will be chorus and flanger. We can define flanger as a comb filter in motion. It is a short delay that is put into motion by an LFO, that's a low frequency oscillator, which applies a cycle motion to a parameter. Very often it's done differently in the left and right speaker to give it a back and forth kind of swirly, white stereo presence. The chorus effect is really multiple detuned copies of the input signal. If we change the delay time, it has an impact to the pitch. The use of chorus is to make it seem that a lot of performers are performing the same part. Let's see how a chorus effect works. I have put a piano track to see how it works. Let's put the piano so we can hear it. The first thing we have to see is the dry, which is the input signal. That's clean signal. The wet signal, we can hear it. It's when the chorus processes the signal. Then we have the delay, which is the delay time, which is measured in milliseconds. Then we've got the rate knob, which defines the frequency, that's the speed of the LFO. We can hear how it acts. Then we've got the depth, and here we set the modulation amount. And the last one is the spread, which spreads the modulation to the left and right side of the speakers. If we set it to 0, we can hear the sound more in the center, and it's much wider when it's 100%. Now we are going to see the flanger effect. The flanger effect works in much the same way as the chorus effect, but it uses a significantly shorter delay time. In addition, the effect signal can be fed back into the input of the delay line. Let's see how it works. To demonstrate the flanger, I've loaded a guitar sound. That's a track with a guitar. So let's hear how it sounds without the flanger. And now, if we put the feedback, we can hear how it changes. The feedback is the amount of the effect signal that is routed back into the input. This can change the tonal color and make the sweeping effect more pronounced. Negative feedback values invert the phase of the routed signal. We can see the dry and wet signal as before, as we saw before. The spread what it does is, as you can hear, put the effect more on the right and the left of the speakers. The delay time, the same as before. The depth, it's the modulation amount as we saw before as well. Notice the difference. And the rate knob defines the frequency, the speed of the LFO. Well, that was all for today. I hope that you enjoyed it, and I hope to see you all next week. Bye everybody!